Hello students, you're most welcome to a new session, and today we'll be looking at organic chemistry, precisely question 5 for the paper February 2023, of course, paper 4-2. The question goes thus: you have propane, propan-1-ol, and propanoic acid are members of different homologous series. Molecules of these substances contain free carbon atoms. A. Explain why members of a homologous series have similar chemical properties. Now, one thing you need to know is that this homologous series or each homologous series have unique functional group, all right? And it is this group that determines the principal chemical properties of that series. So explain why members of a homologous series have similar chemical properties is because they have what? They have, sorry, they have, you can say that they have what? The same functional group, okay? So the reason because they have the same functional group. Name the homologous series to which propanoic acid belongs. Now, for your propanoic acid, the homologous series here should be your carboxylic acid, okay? The carboxylic acid. Now, we'll just run down the others. So if this is your carboxylic acid, now your propan-1-ol should be your alcohols. The alcohols here, your propene belongs to the alkene, as well as your propane that constitute your alkanes. Is that okay? So those are the alkanes. Next question says, state the general formula of the homologous series to which propanoic acid belongs. So you're going to have the alkyl functional group, which is CnH2n plus 1. Of course, then the functional group, the carboxylic functional group. And you should note that your N begins from 0. Your N begins from 0. For example, when N equal to 0, then you're going to have your metanoic acids. Of course, which is the same as, so let me just put a double arrow, which is the same as what? So that's display formula of metanoic acid. So that's for N equals to 0. Now let's continue. The next question says, name this isomer. What isomer? Isomer of propan-1-ol. Now the first question is, what are isomers? What are isomers? So we can define isomers as what? Organic molecules. We can say organic, or we can say molecules. When I use organic molecules, let me just say molecules. The molecules with same molecular formulae, same molecular formula, but different they have different structures. So they're going to have different structures. Write this clearly. That's it, right? The isomer of propan-1-ol, of course, the unbranched isomer should be your propan-2-ol, right? We call them what? Position isomers. Propan-2-ol, or you can say 2-propanol. That's another name. Now, the question here is, can be, is there a branch isomer? Is there a branch isomer of propan 1-ol? Is there any branch isomer of propan 1-ol? If yes, what is that isomer? If no, of course, you can keep your answers in the comment section below. So you can keep your answer there. Draw the displayed formula of this isomer. Of course, it's simple. All you need to do is what? Propan 2-ol should have 3 carbon atoms. 3 carbon atoms. And what next? You could have what here? Let me see. I can decide to name them. Carbon 1, 2, 3. Now, the next thing is that the OH group is on carbon atom 2. So I'm going to put it there. Okay. So you're going to have H here, H here. So that's a propan 2-ol. Next question is propane and propene can be manufactured by heating the cane in the presence of a catalyst. One other product is formed. Complete the equation for this reaction. Looking at this question, you have what? The cane, and you're told that propane is what? Produced, and propane is also produced. Now, what do we do here? Do we know propane? Propane normally is what? C3, right? Now, my propane is C3, but I might be confused on the number of hydrogen atoms in propane. That's what many students go through. So if we come back up here, remember there was a question that tried to ask us the general formula of your carboxylic acid. So we could also have the general formula of the others. Like for the alkenes, you're going to have CN H2N plus 2. And this guy is going to be CnH2n. From this general formula, you can get all the members. Now for propane, for example, propane is carbon atom N equals to 3. So the propane will be what? C3H what? 6 plus 2, 8, right? Likewise, your propene will be, for your propane, you're going to N equals 3, you're going to have C3H6. So you have propane and you have propane. So these are the formulae of these two compounds. All I need to do is I just come here and I fit them. So I'll start with my propane C3H8 and I'll move to my propene C3H6. Good. The product section has used 1, 2, 3, 4, 5, 6 carbon atoms. So how many carbon atoms is left? 10 minus 6. This is the 10 here. So you're going to have 10 minus 6. That gives you 4. Okay. Now, what about hydrogen atoms? This is 4, please. For your hydrogen atoms, I'm going to have what? 8 plus 6, that's 14. So 22 minus 14. That should be about 8. So it means that the other product is your butene. You can say but1ene. That's it. Now name this manufacturing process. Since it's actually heating and you have what? A large molecule which is less useful, broken down to produce what? More useful and highly volatile, simple what? Molecules, then that process is cracking. So that's cracking. It's cracking. Yes. The next question says propane forms a polymer named polypropene. Draw the displayed formula of a section of polypropene showing 3 repeat units. So you're gonna draw 3 repeat units. Take note, we are using what displayed formula. The displayed formula simply means that you have to show all the bonds, okay? Show all the bonds. So take note on that. For you to draw your polypropene, you need to identify that monomer. The first thing is that this monomer should have a double bond, right? And your propene has 3 carbon atoms, so I can put the other carbon atoms there. And that's your propene. That's your propene. The CH3 group can also be here, and the hydrogen take that other position, so it doesn't matter. Good. So when you have that, of course, for you to get your polymer, all you need to do is get rid of what this double bond, and that's it, and extend the chain. So I'm gonna extend my chain. My first repeat unit, taking it, so I'm getting rid of what? Getting rid of the carbon to carbon double bond. So I'll put my first side chain there, and the hydrogen atoms. Can you see that? And you have hydrogen, and you have hydrogen. That's my first repeat unit. Then I'm gonna draw my second repeat unit. So you're gonna have CH3, H, and H, H. That's 2 repeat units. So I'm gonna take my third repeat units now. C3, H, hydrogen, hydrogen. So that's my polymer with 3 repeat units. So this is second repeat unit. That's my polymer, right? Sometimes whenever we're writing the equations, we usually put this. Okay, we usually put N, and it's still acceptable. Now the next thing you need to do is we can also get what sometimes they'll ask you the structural formula. All right. So it is imperative that you have to identify or differentiate between what the displayed formula and the structural formula. Good. Now for the structural formula, I'm gonna have my CH3. All right, gonna have my CH3, then CH, then so I'm gonna put this and carbon hydrogen. Of course, how many hydrogen? 2 hydrogens there. And that's it. So you can keep on the chain. That's it. That's my structural. So this is structural. And this is displayed. Good. So I'm going to go back to my blue pen. State the type of what polymerization that occurs when propene forms polypropene. The monomer has a carbon to carbon double bond, and it's usually what? One type of monomer. So we say that is an addition polymer. It's an addition polymer. The next thing we need to do is we look at propanoic acid reacting with aqueous sodium carbonate to form a salt. So they're testing you on reactions of what? Carboxylic acids. Reactions of what? Carboxylic acids. That's what they're testing you on. So just the name of the salt form. So the salt is usually what? The metal combined with the anionic part of the acid. All right, the anionic part of the acid. So you're gonna check on this too, dude. And that will be sodium. Oh, sorry. This is so just the name. Sodium. Sodium, is it propanoic? Of course. Propanoic, right? So that's the anionic part of carboxylic acid, propanoic. carboxylate. All right, so usually carboxylate, which is like you can put that, usually ends in that format. Okay, so I can put R here. That's carboxylate. Yep. And another thing you need to know here is if it's carboxylate, you can have metanoate. So this would be metanoate. And this metanoate, you could also have what? That's ethanoate, right? So take note of that. So just the formula of the anion in this salt. So we want the anionic part of the salt. So that will be what? Propanoate, right? So the formula was CH3, CH2, and then was COOH. That's it. That's the anionic part of the salt. It is propanoate. That's the formula. The next question goes thus: H. Propanoic acid forms an ester when it reacts with an alcohol, and that alcohol is ethanol in the presence of a catalyst. So here they're talking about esters. Okay, we're talking about esters here. So suggest a suitable catalyst. The catalyst is usually what? An acid. You can put an acid, or you can put sulfuric acid. So you can specify. Sometimes they usually have phosphoric acid. You can have phosphoric acid. Still acceptable. Then name the ester forms. How are you going to identify the ester form? The ester, you're going to have what? The ethanol, the alcohol part first. So this one is usually first during naming, and this is what? Second. All right, during naming, we start with the first. So since it's ethanol, we get the alkyl part, which is what? Ethyl. And we have propanoic acid, we get the anionic part, which is what? Propanoate. We have propanoate. Draw the displayed formula of this ester. Draw the displayed formula of this ester. So what are you gonna do? We want ethyl ethanoate or propanoate. Now we're gonna, when the structure is concerned, we start with what? The propanoate. So we're gonna have this, and I like to draw my ester on first. Okay, so you can have this. And then your ethyl now. Your ethyl is 2 carbon atoms. So that's 2 carbon atoms. We can do a quick revision on this, whereby this is your ethyl, and this is your propanoate. And another pen, where this is what? This is your ester bond. What is this? This is your ester bond, okay? That's an ester bond, or you call it ester linkage. That is that concerning the organic part of this question, and I wish to thank you all for your collaboration. If there's any question, please keep your comments or your doubts in the comment section below. And don't also forget to subscribe to this channel, and see you at the top. Thank you.